In section 5.4, we talk about multiplying polynomials. Properties of real numbers and exponents are used continually in the process of multiplying polynomials. To multiply monomials, for example, we apply the commutative and associative properties of real numbers and the product rule for exponents. As a reminder, the product rule for exponents says that if we multiply two terms with the same base and they have exponents, then we can just add the exponents together. So to multiply a monomial by a polynomial other than a monomial, we use the expanded form of the distributive property. So we would just distribute the a to all the pieces inside the polynomial. So let's go ahead and do this with example number 1. We have negative 3x squared times 4x squared minus 6x plus 1. We are going to distribute negative 3x squared to all three pieces. And so negative 3x squared times 4x squared, negative 3x squared times negative 6x, and negative 3x squared times 1. So we want to multiply the numbers together, and then we are going to add the exponents on our x's. So negative 3 times 4 is going to give me negative 12, and then x squared times x squared gives me x to the 4th. Negative 3 times negative 6 is positive 18, and x squared times x is going to give me x cubed. And then negative 3x squared times 1 just gives me negative 3x squared. And we can't combine anything because we don't have any like terms. What about for the second one? We want to make sure that we distribute negative xy to all three pieces in the trinomial. So we get negative xy times 7x squared y, negative xy times 3xy, and negative xy times negative 11. And so we're going to approach this the same way. We have negative 1 times 7, which gives me negative 7. I have x times x squared, which gives me x cubed, and y times y gives me y squared. For the next term, we have negative 1 times 3, which gives me negative 3. X times x gives me x squared, and y times y gives me y squared. And for the last term, we're just going to get plus 11xy. Now, when I multiply two polynomials, we use the distributive property and multiply each term of one polynomial by each term of the other, and then combine any like terms. So looking at example number 2a, this means that x is going to get multiplied by 2x, and x is going to get multiplied by 5. And then we have to move to the next term. 3 is going to get multiplied by 2x, and 3 is going to get multiplied by 5. So we just distributed twice. And we want to make sure that we combine like terms when we're done. So we have x times 2x we have x times 5. We have 3 times 2x. And we have 3 times 5. So you'll see that the numbers written in black did not change. The only thing that changed was what was being distributed to them. So let's go ahead and simplify. X times 2x gives me 2x squared. we've got 5x plus 6x plus 15. And we have like terms in the middle that we can combine together. And so we get 2x squared plus 11x plus 15. Let's go ahead and try the second one. So we have a binomial times a trinomial. This is going to work the exact same way. So the first thing we're going to do is we're going to distribute the 2x to all three pieces. And then we're going to distribute the -3 to all three pieces. So we have 2x times 5x squared we've got 2x times -6x, and we've got 2x times 7. Then I want to do the same thing with the -3. We've got -3 times 5x squared. We've got -3 times -6x. And we've got -3 times 7. So again, the numbers in black didn't change. The only thing that changed was the number up front that we were distributing. So let's go ahead and simplify. 2x times 5x squared gives me 10x cubed. 2x times -6x is -12x squared. 2x times 7 is going to give me 14x. And then -3 times 5x squared gives me -15x squared. -3 times -6x gives me plus 18x. And -3 times 7 is -21. We want to make sure that we combine like terms. And so I have a -12x squared and a -15x squared. I also have a 14x and an 18x that can be combined. So we get 10x cubed minus 27x squared plus 32x minus 21. And you just want to make sure this is written in descending order, which it is. Now what about multiplying binomials? When multiplying a binomial by a binomial, we can use a special order of multiplying terms called the FOIL order. This stands for first, outer, inner, last. But what you're doing is you're just distributing like what we did in the previous example. The only thing this is going to be helpful for is if you have a binomial times a binomial. And it's just to help you memorize the order so that you can hit all of the terms necessary. But we're doing the exact same thing. So when it says the first terms, that's the 2x times the 3x. The outer terms are the 2x and the -4. The inside terms are -7 and 3x. And the last terms are -7 and -4. But I just did the exact same thing that I did in the previous example. So we have 2x times 3x. I've got 2x times -4. I've got -7 times 3x. And I've got -7 times -4. And so let's go ahead and simplify. 2x times 3x is going to give me 6x squared. We've got 2x times -4, which is -8x. -7 times 3x is -21x. And -7 times -4 is plus 28. So we can combine like terms in the middle, negative 8x and negative 21. And so we end up with 6x squared minus 29x plus 28. The square of a binomial is a special case of the product of two binomials. Now, by the FOIL order for multiplying two binomials, the first thing that you want to do is rewrite this as the binomial times the binomial. So a plus b squared is just a plus b times a plus b. And then you're just going to do the exact same thing that we did beforehand. You could memorize the formulas for these if you want, and they're in the purple box below. So when we're done, a plus b squared is going to turn into a squared plus 2ab plus b squared. And a minus b squared is going to turn into a squared minus 2ab plus b squared. But again, what you can do is you can just write it twice and then distribute and multiply. So I'm going to show you both for this first one so you can see what ends up happening. X minus 9 squared just means that I have x minus 9 times x minus 9. We are going to distribute the x to both pieces, and then we're going to distribute the negative 9 to both pieces. And so we end up with x squared minus 9x minus 9x plus 81. We can combine like terms in the middle, and so we get x squared minus 18x plus 81. That's using the long method. Now, if you wanted to just memorize the formulas, the first thing is we need to see what is A and what is B. So A in this case is x, and B is 9. We need to plug it into the second one because it's A minus B squared. And we should get A squared minus 2AB plus B squared. And so x minus 9 squared is going to become a squared, which is x squared, minus 2 times x times 9 plus 9 squared. That gives me x squared minus 18x plus 81. So it's the exact same thing. So if you forget the formula, you can always just go ahead and multiply like we've been doing. Let's go ahead and just use the formula for this second one. We get A equals 3x and B is 2z. And so we're going to use the first one because we have a plus sign in the middle. So plugging in, we have 3x squared plus 2 times 3x times 2z plus 2z squared. Now you need to make sure you remember your exponent rules here. So that squared is going to get brought to both pieces. And so we end up with 9x squared. In the middle, we have 2 times 3, which is 6, and 6 times 2, which is 12. And then we have x and z. And then for the last term, we're going to get 4z squared. So just be careful. A plus b squared is not going to give you a squared plus b squared. You are missing that middle term completely. Same thing goes for a minus b squared. This is not going to give you a squared minus b squared. So make sure that you either memorize the formula or you just write it twice and then FOIL it. Now another special product applies to the sum and difference of the same two terms. So a plus b times a minus b, when I simplify, is going to give me a squared minus b squared, because the two middle terms are going to end up canceling. So I'm going to show you that you can do both methods, one just by distributing and the other one by memorizing the formula. So we're going to distribute the x to both pieces and distribute the -3 to both pieces. And so x times x gives me x squared. We have plus 3x, minus 3x, and minus 9. And so our middle terms are going to cancel. And we end up with x squared minus 9. If I did it the other way, my a is x and my b is 3. And so a minus b times a plus b gives me a squared minus b squared. But that's x squared minus 3 squared, or x squared minus 9. So same thing. And for the second one, we're just going to use the formula. In this one, a is going to be 4y and b is 1. And so plugging it in, we end up with 4y squared minus 1 squared. You have to remember to distribute the square to both pieces. And so we end up with 16y squared minus 1. And if you were to multiply this out the long way, you would get the exact same answer. And what if I want to multiply 3 or more polynomials? So more than one method may be needed, but we just want to look at 2 at a time and then simplify, and then we can keep multiplying. So for example number 6, the first thing I'm going to do is I'm going to multiply x minus 3 times x plus 3 first. But we know that this is a difference of squares. And so in this case, your a is x and your b is 3. And so a minus b times a plus b gives you a squared minus b squared. But that's x squared minus 3 squared, or x squared minus 9. And so now we can rewrite this first 2 as x squared minus 9, and we still have x squared minus 9. But we have the same term twice. So we could just shorten this to x squared minus 9 squared. And then we can use the square of a binomial to go ahead and finish this out. So my a in this case is x squared, and my b is 9. And so when I have a minus b squared, that gives me a squared minus 2ab plus b squared. Well, a is going to be x squared squared minus 2 times x squared times 9 plus 9 squared. We're going to multiply our exponents together and we get x to the 4th. We have 2 times 9, which gives me negative 18x squared in the middle, and 9 squared gives me 81. Now you could have multiplied this entire thing out the long way and you would have gotten the same exact answer.